All right, this is Unit 3, Formative 3, Day 5, Application of Systems. So these are going to be the word problems or the sentence response. All right, first thing, which method would you use? Remember, we graphed, we did substitution, and we did elimination. So just to remember, graphing, we like to graph when our equations are y equals mx plus b. Okay, so whenever it looks like y equals mx plus b, we are going to graph. Substitution is when one equation has y equals or x equals. So we can substitute that easily into the other equation. And elimination is nice when my x's and y's line up. So it's easy to multiply and then add. All right, so let's take a look at these. Okay, the first example here. All right, now we don't have y equals mx plus b, so we're not going to graph. Okay, and we do not have one equation solved for x or y, so we're not going to do substitution. So elimination would be best for this one. Okay. The next one, both of them say y equals, okay, and 3x minus 1 and 4x. So these are in y equals mx plus b form. So these would be best solved if we graphed. And then the last one, okay, we have 5x plus 4 equals 9, which is standard form. However, this one says y equals 2x minus 1, so we could easily substitute this in for this y. So this one would be a substitution. There will be a question like this on the test, so make sure you know when a good time to graph, eliminate, or substitute would be. All right, when graphing a system of equations, explain how you know if it has one solution, no solution, or infinitely many solutions. Okay, so we're not talking about true or false because we're actually talking about graphs. So if I have a graph, okay, if it is a one solution, what do you know about the two lines? Okay, if it's one solution, we know the two lines meet at one point, so we have one solution. If it's a no solution, what do we know about the two lines? Okay. Remember, no solution means they're not going to meet. So these two lines would be parallel. Okay. And infinitely many solutions means that they meet many times. So this one is where they would look like the same line. Let's see if I can do that. Oops. The same line. So they meet everywhere. Okay. So a one solution is they meet in one spot. No solution is when they're parallel and they'll never meet. And infinitely many solutions is when it looks like the same line. All right, let's look at some word problems. Okay, there's two types of word problems. Okay, the first one is a break-even point, or when are they going to be the same? A fashion designer makes and sells hats. The material for each hat costs $5.50. The hat sells for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay. This is a very popular business. Anyone that starts a business, they have to ask themselves this question. So they know monthly if they're going to sell enough hats or whatever they're selling. Okay. So whenever you see this break even, okay, your equations are going to be y equals and y equals. Okay, where y is going to be their break-even point. Okay, now one equation is going to be the cost that the person puts out. The other one is the profit. Okay, so let's take a look at the word problem again. So we're going to distinguish between cost and profit right now. All right, so the material for each hat costs $5.50. Okay, that is cost. Okay. So that is a cost. The hat sells for $12.50. That's a profit. Okay, we'll do that. That's a profit. And the designer spends $1,400. That, again, is going to be a cost. Okay, so we have two costs, and we have one profit. All right, so let's put those in equations. Let's look at the cost first. Okay, first of all, no matter how many hats the person sells, it's going to cost $1,400. No matter how many they sell, they are going to spend $1,400. Okay. Now, the other cost is the hats, okay, per hat. It costs $5.50 of material for each hat they make. Okay, so $5.50 depends on how many hats they sell. So this is going to be a multiplication problem, because if they sell 2 hats, it's $11. If they sell 1 hat, it's $5.50 plus the $1,400. So this will be $550 times X, X being how many hats they sell. Okay. So there's our equation for cost. It's $5.50 for every hat plus the $1,400 every month on advertising. Now, profit. The only thing we have for profit is $12.50, okay? But it's not $12.50 period, it's $12.50 for each hat. So this one would be $12.50, and X is our hat. Okay? So here are our 2 equations. Okay? Now, we're not going to graph, because 1,400 as our y-intercept here would be a really big graph. Okay? So we're going to do substitution. So we're going to take this equation and plug it in to the other one. So I have $12.50 times for hats equals $5.50 times the number of hats plus the $1,400. Okay, so I'm going to move the 550 over. Okay. Then we get 1,400 here, because those cancel, and this is 7x, or $7. Divide by 7, and x equals 200. And what is x again? X is hats. So they have to sell 200 hats to break even. Okay? You do not need to go find out what y is, okay, on this. All they want to know is how many hats they need to break even, and it's 200. All right, so again, this is one that has a break-even point. Okay, whenever you have a break-even point, you're going to have y equals, and y equals as your 2 equations. All right, let's look at one that's not a break-even point. The next type of application problem is dealing with money. You have a jar of pennies and quarters. If you grab 51 coins out of the jar and it totals $4.35, how many were pennies and how many were quarters? Okay. On this one, we're going to have 2 equations, okay, because it's a system. The first one is going to deal with quantity. The second one is going to deal with the money part. Okay, so quantity, we know we have 51 coins, and we know that their pennies and quarters have to equal 51. Now the money, we know that it equals $4.35. Okay. Now pennies with money is worth 1 cent. And quarters are 25 cents. Okay. I'm going to rewrite that. Nicer. Just like if you had a nickel, you'd have 0.05. If you had a dime, you'd have 0.1. Okay. All right, first thing I'm going to do, there's our 2 equations. The first thing I'm going to do is get rid of the decimals in this equation. Okay, so I'm just going to move my decimal over 2 times, which basically means I'm multiplying by 100. But if I multiply this by 100, I have to multiply this one and this one. So I'm going to move all these decimals over 2 times. Right, then I'm going to bring this equation under this one. All right, now these are set up and they're in order, so I'm going to look to do elimination. And I have a 1p and a 1p, so if this one were a negative, my p's would cancel. So I'm going to go ahead and multiply this bottom one by -1. So I get -1p minus q equals -51. I'm going to bring this other equation under it so it lines up. So 1p plus 25q equals 435. So I have 25q, because those cancel, equals, and then 435 minus 51 is 384, and then when I divide by 25, I'm running out of room. I'm going to go ahead and come on up here. Q equals 16. So that means there's 16 quarters. Now I need to find out how many pennies there were. Back up here, I know that they had a total 51. So if I put 16 in here for quarters, so I have pennies plus 16 quarters has to equal 51. Subtract 16. $35 pennies. So 35 pennies and 16 quarters is the answer. Make sure you guys get this stuff down. There's problems like this on the test, and we will do some in class. You guys have a good day.